Okay, let's begin with section 1.1. These are some basic definitions that we're going to be using throughout the year. These are all things that you've heard of, but you might have forgot some of the names. So we're just going to go over these real quick. A variable is just a symbol that is used to represent one or more numbers. N, X, sometimes you'll see the variables Y. Sometimes you'll see the variable M and X. Sometimes you'll see B. So they can be any letter of the alphabet, and as you might know, this is the slope-intercept form of a linear function. The numerical expression, it's just an expression with numbers. Numbers, 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 numbers. This whole thing is an expression. This whole thing is an expression. Algebraic expression, this is going to be an expression that's actually involving a variable, like right here, and like right here, and like right here. So if it has no variable, it is a numeric expression. If it has a variable, it is an algebraic expression. One thing to note is that these are not equations because there's no equal sign. Constants are values whose quantity does not change, such as the number 6, negative 34, 9.87, any number, like radical 2, something like that. Any of those numbers are just constants, and that is it. So now that we've got some basic ideas down, let's take a little bit deeper look at numbers and refresh our brain cells about the different types of numbers. As you can see here, this is all of the real numbers that we know, and they're broken into subsets. The very basic subset of real numbers are just the natural numbers, the counting numbers. These are the numbers that we all learned when we were kids growing up on how to count anything from lollipops to bikes to Pokemon cards or whatever. Whole numbers are the same thing as counting numbers, but it's involving the concept of zero. In other words, a number that represents nothing. Next step would be the integers. These would be all the whole numbers, but now we're including positive and negative numbers. And again, these are still all whole numbers, but they're both positive and negative. That represents the integers. Rational numbers, these are numbers that can be written as a fraction where the decimal value is repeating or terminating. So in other words, they terminate, like this one right here, 1/8, 1.25, or that they're repeating, that's what the little bar represents, 1/3 equals 0.3333 repeating. Irrational numbers are numbers whose decimal values do not terminate, nor do they repeat. For example, radical 2, as you can see right here, this decimal value of radical 2, if you plug that into the calculator, you'll see that that's going to be represented right here. There is no pattern for the decimal values, and the dots there do represent that it does not terminate. Therefore, it would be an irrational number. A very popular irrational number would be pi, radical 2. Usually, if you see a radical sign, that means it's going to be irrational. But that's not a guarantee, because if you think about it, what's the square root of 9? Well, that's equal to 3, and 3 is not irrational. As a matter of fact, it's a rational number, and it's also an integer, and it's also a whole number, and it's also a counting number. Let's take a look at this multiple choice question right here. They're asking us to classify the variable, and it says your school is sponsoring a charity race. Which set of numbers does not contain the number of people, P, who participate in the race? So they're trying to find out which one of the subsets would not represent people. Well, one thing I do know about people is that they're whole people. There's no half a person or a third of a person. So I'm probably going to sit here and think about maybe the natural numbers will work because you can count people. Rational numbers you can write, let's say we counted 10 people, you can write that as a decimal value, or excuse me, not a decimal value, but as a fraction. For example, 10 over 1. That would equal 10, and the decimal value would be terminating. Integers, you could have positive or negative. Now, granted, we can't have negative people, but we can still have positive whole numbers. The last one, D, here is irrational numbers. You're not going to have radical 2 number of people or radical 5 number of people. It just doesn't make sense. Your answer there is going to be D. Take a look at this next one and answer it on your own. You might want to start thinking about what type of numbers has decimal values. Well, that idea came up with rational and irrational numbers, and as you can tell, rational numbers is going to be your best bet, and here's why. Think about the decimal value, or the dollar value of $15.50. Does the dollar value end, or does it keep going? Well, it ends right at 50, therefore it terminates, and you're going to have a rational number. Okay, getting back to some more basics about algebra, let's talk about graphing numbers on a number line. It sounds kind of simplistic, but as Algebra 2 students, we're going to be using a lot more sophisticated numbers than just your basic counting numbers or your whole numbers. So I wanted to go ahead and take a look at this set of numbers and put them on the number line. Well, let's take a look at negative 5/2. This is the same thing as negative 2 1/2. So I'm going to go to negative 2 1/2. I'm going to keep going in this direction. It's going to be our negative 5/2 and 2.6. So that's probably going to be somewhere in the middle here. I am one of those teachers that does not get too detail oriented, just as long as it's in the semi-correct location. I am not going to get out my laser and measure exactly 2.6 units from 0, but I do want to make sure it's in the right location. The last one I'm just not too sure about, so I'm going to go over and check my set of radicals here. And I went ahead and numbered these 1 through 20, and I want to check to see where radical 2 lies. Well, let's take a look at radical 1 and radical 4. I know that radical 2 is between those two, so the value for radical 2 must be between 1 and 2. So if I go over to 1 and 2, I'm just going to go ahead and pick a value right here and just say that that's going to be the same thing as the square root of 2. Same thing can be done with radicals and decimal values with using the inequalities, greater than or less than. So let's take a look at radical 17. I'm going to scroll down here a little bit, and we're going to see radical 17 right here. Looks as if it's real close to 4. Now, it's greater than 4 because it's radical 17, which is greater than radical 16. So I know that radical 17 is greater than 4, which means it's also greater than 3.8. I want you guys to try this one right here. I got radical 25 down here, so that might be able to give you a clue. And hopefully you figured out that radical 26 is close to 5, and radical 36 is equal to 6. So this radical 26 is nowhere near radical 36, so it's probably closer to this value 5 than it is to 6. That doesn't even matter because 6.25 is greater than 6. So it's real simple inequality. 6.25 is greater than radical 26. I strongly suggest that you create some type of radical stack right here to help you with some of the homework problems. Next, let's talk about the properties of real numbers. As you can tell, I've gone ahead and highlighted some of these, and these are listed in your book or online. And these are just basically definitions that you're going to need to know: commutative, associative, identity, inverse, and distributive. Remember, this is commutative, not commutative. It's not community, it's commuting. One word that is a synonym for traveling is commute. So commutative means these are going to be traveling. As a matter of fact, take a look. For addition and multiplication, these did travel. A was first, B was second. Now B was first, A was second. Same thing with multiplication. These flipped. They traveled, which means it was the commutative property. The associative property just talks basically about who you're associated with. Who are the things you hang out with? Who are the people that you hang out with? And here, A and B are hanging out. Here, B and C are hanging out. But for addition, remember, it doesn't matter who you're hanging out with. With addition, it's all going to be the same. Same thing with multiplication. Hanging out with AB times C. This is still read as A times B times C. This is the associative property. Identity property talks about what happens when you add 0 to something. Well, nothing changes. You retain your identity. 0 plus A, again, you retain your identity. Same thing for multiplication. 1 times A, you retain your identity. 1 times A, you retain your identity. Inverse, probably thinking opposite. That's true. A plus its opposite is going to equal 0. And A times its inverse. Now this is not an opposite, so it's a little bit different than addition, but the multiplication is its inverse, which means flipped. So if you think about it, A is the same thing as A over 1, and that's, if you multiply that out to 1 over A, and just multiply that straight through, you're going to have 1 over A, which is the same thing as 1. Which is exactly what happened here. It's the inverse property. This comes in really handy when you're trying to simplify fractions. We'll talk more about that later as the year goes on. The distributive property, real straightforward. A times B, A times C. And that's it for these properties. Tackle these two and see which property is represented here and here from this little chart. I hope you had the inverse multiplication. And on this one right here, let's take a look. We had 3 times 4 times 5, and what has changed? The association between the first two has not changed. In other words, they're grouped together, 3, 4, 4, 3, but something has traveled, something has moved. So this would be the commutative property of multiplication. And now I want you guys to take a look at this one right here and see which property or properties is illustrated here. Hopefully this one was straightforward and you knew that it was the distributive property. For multiplication. Now, if you didn't see that, think about this. This is 3G here and 3H here. That was a simple distributive property. Hopefully you guys will again take a look at these properties and also the number lines and the radicals to help you out with tonight's homework. And I'll see you guys tomorrow in class.